Hi folks, welcome back. In case you missed it, check out our previous episode where we talked about the ins and outs of data preparation and transformation. Now, on the aspect of data familiarization, let's talk about a moment we've all had. You open a dataset and stare at columns named age, sex, or mysterious ones and twos, and felt that familiar sense of confusion and dread. Who decided one means female and two means male? Is age measured in days, months, or years? How was blood pressure or body mass index calculated? Those specific attributes are metadata. Stuff like age in years, weight in kilograms, or female being 1 are the tiny instructions that stop analysis from becoming educated guesswork. Today, I'll show you how to automatically extract a full data dictionary and export it to Excel, so that your future self and everyone you share the file with can stop playing detective. Let us look at one of the simplest but most powerful tools in quantitative work, the data dictionary. Whether you're cleaning a dataset, building models, or handing results to collaborators, a clear dictionary prevents mistakes, speeds work, and makes your analysis reproducible. A data dictionary is a compact, structured record of what each variable means, how it's stored, and how its values are coded. Think of it as the map that lets anyone, including your future self, navigate the dataset without guessing. Without that map, small misunderstandings about units, missing value codes, or recoding decisions can snowball into an avalanche of wrong conclusions. A useful dictionary is short, precise, and machine-friendly. At minimum, it includes attributes of the data such as variable name, variable label, storage type, units, value labels, missing value codes, and a provenance note. In the next segment, I'll walk you through a compact data script that builds a data dictionary and exports it to Excel. We'll look at how to use data frames to post results, write nested loops with built-in validation checks, and leverage macros to pull out the metadata we need from datasets. By the end, you'll be able to run this workflow on any file and generate a clean, polished, and shareable dictionary. First, the script finds non-string variables, specifically count and factor variables, and stores their names in a local macro named int_vars and creates a new frame called data_dct. But let's pause for clarification. In this and other coding scripts, you'll notice a naming style where variable names are built from full or shorthand words separated by underscores. This is because there are rules to naming variables, including a limit on characters in the length of the variable name and no use of white space. Variable naming styles include the snake case, where the words are separated by underscores, the camel case, where the first letter of every subsequent word after the first word is capitalized, and the Pascal case, where the first letter of each word is capitalized. How you choose to name your variables is entirely up to you and the needs of your analysis. The key is that the human-readable label attached to each variable gives enough information for anyone to understand what it represents. Now back to the code. The attributes, variable name, label, type, label name, and value labels will be written as strings on the frame data_dct. Because each field has variable length, we set the storage type to long string format at this time. Next, we process the numeric variables. We begin the loop by checking if there are actual variables to process. This is done by checking if the local macro int_vars is not empty by using the macro function word count. If the check evaluates to true, then we move on to the next level in the loop, where for each variable we capture its name, label, and storage type and store these in local macros. Then we check whether the variable has a value label attached to it using the macro function value label and passing it through the word count function. This serves to separate factor variables from continuous variables, effectively killing two birds with one stone. If the word count expression evaluates to not empty, then we capture the label name, get the distinct levels of the factor variable, and build a new line separated string of value label pairs. If the word count expression evaluates to empty, then this means the current variable is count and does not require value labels. Thus we set the label name and value labels to NA. Finally, we post the extracted metadata as individual rows for each variable into the data_dct frame. The next code block repeats the process for string variables. We identify string variables using the ds command and store them in the str_vars local macro. We begin the loop by evaluating if any string variables have been captured from the data using the word count macro function. Then we proceed to extracting the variable name, label, and storage type. Since strings don't have value labels in the same way as factor variables, we simply set the label fields to NA and post the extracted metadata to the same data_dct frame. Finally, we compress the frame so that column widths are dictated by the longest string or number in the dataset, and this helps to save space. We add human-readable labels to each of the variables and export the dictionary to Excel. Et voila! The output is a clean sheet with every variable and its metadata. For categorical variables, you can see the value label mapping in the value labels column, separated by new lines so they are readable. I have also added in my code and output columns for the total number of observations in the dataset, number of missing observations, and the fraction of missingness as a percentage for each variable in the dataset. A data dictionary pays you back many times over by speeding up exploratory analysis when there is a clear distinction between categorical and continuous variables and what each code means. Decisions such as when to summarize and when to plot are made easy straight from the jump. Preventing modeling errors through clear unit and coding allocation. This assures that factor variables are modeled correctly and ordinal variables are not treated as continuous. Supporting reproducible pipelines by documenting derived variables and exact recoding rules. This allows anyone to rerun your preprocessing and get the same inputs to a model. Improving collaboration and review in a multidisciplinary team. This means that statisticians, clinicians, and data engineers can read the same dictionary and align definitions before writing code or interpreting results. Finally, the data dictionary helps in quality assurance and auditing. It makes it easy to spot unexpected values, missing value conventions, or inconsistent coding across waves or sites. Remember to make the data dictionary machine readable and human friendly. It can be a spreadsheet with columns for variable names, labels, data type, measurement units, missing observations, and notes for provenance. Automate its extraction where possible so that the dictionary stays current after cleaning. Join me in the next episode where we will use descriptive statistics and charts to make sense of the data, uncover early patterns, and refine research questions that will guide the rest of the analysis. I am your host Andrew, and this is Monkey with a Keyboard.